let's look at some ways we can use the format function or property in Access to display dates with times in specific formats for different purposes in forms and reports. Before we do that, though, let's start with a review of some of the things we know about how Access stores dates and times internally, so we can see how to use that information when we do the formatting for display purposes. We have here a couple of functions, date and now, that are going to return dates and times for us to look at. Notice that date, as you probably already know, returns the current date. Now also returns the current date, but it includes the time as well. Oh, notice, by the way, that I'm using the US regional settings for my Windows operating system, which presents dates as month, day, year. This is a formatting issue right off the bat. If you're using different regional settings, you may see day, month, year in that format. Just keep that in mind as we're working through these examples. Because we have the same date in both cases, the next question that came to my mind is, well, are they returning the same value? Is the value of now equal to the value of date, and we're just not seeing that time here? Well, the answer is no, false. They are not the same. That brings up another question. Well, if date is returning only the day and not the time, how does Access actually store those values when I go to put them into a table? We can force Access to give up its secret by using the format function in combination with the date and now functions to see what's really happening underneath what we see in that display. Format causes Access to display the result as the month, day, year, hour, minute, and second. And we're going to apply that same format to both date and now. And then we're going to repeat our comparison to see if, or to confirm, I guess, that they are not the same. Aha! When Access does not have a specified time, as in the value returned by now, it uses the default time, which is 12 a.m. or midnight, 0 hours on that date. And now you can see very clearly why the comparison fails. Those two are different and they are false. This has implications, again, to repeat, when you're doing date comparisons in certain calculations where you want to know elapsed time or whether something happened on the same day or not. If you're comparing the same underlying values, you're going to get valued results. But if you don't take into consideration the fact that even though you don't see it, there is in fact a time component to all dates, you can come up with some interesting and inaccurate results. So, the next question. Why does the default time value for the date function equal midnight? And if there is a default time value, is there also a sort of default date value? And of course the answer is yes, there is a default day. It is the first day, or day 0. What do we mean by that? Let's just quickly find out by using the cdate function to convert these values to dates. CDate, or convert date, takes a number and returns the equivalent date. We'll do that first with 0 and 0.5. You can probably guess what's going to happen, but let's just see. Zero returns midnight, 0.5 returns 12 noon, or half a day. Neither of them returned the default day. And that's an interesting result, one that I might not have expected, one that you might not have expected. But if you've worked with Access for a while, you probably know that that's what's going to happen. Well, let's zero in on what that day 0 is. We'll look at day 1 and see what that value is, and then we can work backwards from that to get day 0. Again, we're going to use the convert to date value on 1 and the convert to date value on 1.5. Make sure I've got it set up here the way I want it, and now we see day 1 is December 31st, 1899, and day 1.5 is the same date, December 31st, 1899, at 12 noon. Pretty much what we'd expect. So we're getting closer. Let's take another dive a little deeper. Let's look at the value returned for -1. We're going to convert -1 to the date. And this time we get December 29th. So day 1 is December 31st. Day -1 is December 29th. That tells me intuitively that day 0 must be December 30th, 1899. And that is in fact the case. Day 0 in Access, I've heard it referred to as the epic date. That comes from a different database system, I think MySQL. But it is the day 0 from which all other dates are calculated. So let's step up here now. And this time we're going to use date 1 minus 1.5. To further confirm this. And whoops, we get a result that we might not have predicted. It still tells me that day -1 is December 29th, but now it's telling me that the 0.5 refers to 12 hours forward, or noon, on the 29th. This is just by illustration of being very careful about how you work with dates, because some of the results may be predictable, other results may not be predictable. Expand this out so we can see. Let's do some comparisons using format. And again, we'll use the format function to force Access to reveal all of those internal values. The date with the time, 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 the date with the time. This is the one, of course, that we're primarily interested in here, because we're trying to figure out what day 0 is and verify that we've got the right answer. And now we can see, yes, day 1 is December 31st, 1899 at midnight. Day 1.5 is the same day at noon. Day 0 is now confirmed to be December 30th at midnight. Day -1, the day before, midnight. day minus 1.5 the day before, but noon of that day. At this point, I think we have established a baseline for which we can compare other ways to use the format property to force different displays of dates. Okay, now we have taken a look at how Access actually stores dates internally as a date component with a time component. Let's look at some of the ways you can impact the way those dates and times are displayed to your users in forms and reports and potentially queries and other places. Keeping in mind that all of the dates that are stored in this table are in fact date with time, we're going to use formatting to cause a different display of each of those values in the resulting fields. First, I have a field with no formatting applied at all. This is the base default in a table. Long date and general date are two built-in formats. Long date forces the display to show the weekday, month name, month date, and year. General date shows the same information, month, date, year, as digits and includes the time. The rest of these are custom formats I created to illustrate some other ways in which you can modify the appearance or the display of dates. And again, just to drive the point home, in these fields in this table, all of the values are stored exactly the same date and time. When you see that they look different, that's because of the formatting, not because the dates and times are different. Year, month, day format returns the 4-digit year, the 2-digit month, the 2-digit day. When we include the hour, minute, and second, we get the same information, year, month, day, along with the time. The 2-digit month and year returns only the month value and the year value, omitting the display of the date. There are ways to display the name as a 3-digit abbreviation or fully spelled out. You can even display just the day and the year, although I can't think of a circumstance in which I would actually use something like that. It is entirely possible, and I included it as a way of illustrating what you can do with custom formatting. Final one I have here for you to look at is the 4-digit year, 2-digit month, 2-digit day, and this is what I think of as the kind of standard display format for dates. It's the ISO standard, and universally it's used across other database systems for presentation of dates. Okay, we have looked at the formats themselves. Let's see the resulting appearance of the same date. And again, to reiterate one more time, these are the same dates in all these fields. They just look different because of the formatting. No format shows the default month, day, year, and then the time. Long date shows the weekday, month name, month date, and year. If I put focus into that field, you can see that the underlying date value is exactly the same as the first field. It's just displayed differently when we remove focus and let it go back and apply that format. The same is true of general date, except that because general date returns the same appearance as the no format date, we don't see the fact that the formatting is being removed. It looks the same. Year, month, day Again, if we focus on that field and see the actual value stored as opposed to the formatted value, it changes. Year, month, day with the hour and minute. And I believe that is second, yes. The 2-digit year and date, and again, we can show December 2018, even though the underlying value stored is December 7th at a specific time. The 3-character abbreviation, the full spelled out month. As I said, this one I can't think of any practical use for it, but you can format with just the day of the week and the year. And finally, the standard year, month, day format, which is employed by virtually all major relational database management systems and the underlying date. So that's a quick look at how you can use formatting to create custom appearances for dates in your applications. You might, for example, want to save space in a report by displaying a value as only the month and year, either the digits or the abbreviation. Or you might want to display it in a more universal standard way by using the month, day, month, the year, month, day format, and so on. The possibilities are pretty extensive, limited mainly by your imagination and practicality.